Okay, so this is a special case of quadratic. You have something squared equals a number. But the first thing you need to do, I'm just rereading it. The first thing you need to do is get the square completely by itself, right? Okay? And then you're simply going to take the square, not root, but what? Roots plural of which side? Both sides. Because remember, you can do anything you want to as long as you do it equally. Okay? So here we go. So let's look at this explanation. Shh, guys. Come on. You can copy it off of somebody else in a minute. So we have x squared equals 9. First of all, how do I know this thing is an equation?
Equal symbol.
Equal symbol. How do I know it's quadratic? Exponent of 2. Now look at this one. This one is a special case because we have x squared on one side. So that's a square, right? And we have a number on the other side. Do you see it? If that's the case, then we can do this special case. We'd have to get the x squared by itself. But is the x squared by itself?
Yes.
Yes, it's on one side by itself. So all I need to do is take the square root of what? Both sides. Now the square root of what the square root does to a square is they simply eliminate each other. They are opposites. Okay? So the square root and the square are opposites. So that just leaves you x on this side. Because it's what times itself makes x squared. X. Okay? Now, on this side, what times itself makes a 9? 3. But remember I told you roots plural, right? So here's the weird thing, if there's anything weird about it. You get a positive 3 and you get a negative 3. Now, guys, let me show you why. If you square a positive 3, what do you get? 9. If you square a negative 3, what do you get?
Minus.
No. Negative times a negative is a positive. So both of those give you 9, don't they? So that means there are two numbers that would multiply times themselves to give you a 9. And that's why there are two roots.
Is that
now,
for everything?
usually, yes. Usually when you see this symbol, you only want the principal or positive roots. But remember, we started off with what kind of equation? Quadratic. Which means how many solutions do I have to have?
2.
And the only way to get them is to have both the positive and the what? Negative value. And now it's solved. That's our answer.
What if it said x is how?
Well, then it's not quadratic. So don't worry about it.
What was the second step?
Okay? Just take the square root of both sides. Square roots of both sides.
For the solution
All right.
of quadratic.
Yes. Still let you see your notes. Okay, here we go, guys. Let's look at another one. Say I have y squared equals 25. Is it an equation?
Yeah.
How do I know?
Because it has this
Equal symbol. What kind of equation?
quadratic.
How do I know?
Because it has
Highest exponent is a 2. Notice that it's y squared equals a number. So is it the special case?
C.
Yes, because it's something squared equals a number, right? Now, what if it was y squared plus 3x equals a number? Is that the special case? No, because this is squared, that is not, right? So do you see the difference? Okay, don't worry about that one. All right, okay. Now, so don't worry about it because I just made it up. It probably wouldn't work anyway. So here we go. Now, what we're going to do is we're going to simply eliminate. So first of all, we need the square to be by itself on one side. Is it?
Yes.
Yes. So we're going to unsquare it by taking the square root. But if I take the square root of this side, what? Do the other side. The square root of y squared. What times itself is y squared? Y. What times itself is 25?
5.
But I need both roots, so it's not only 5, but also what? Boom, done. I told you it's so easy. And you don't need the plus, but it doesn't hurt to put it if you don't want to. You don't have to write it, but it doesn't hurt. Okay?
My entire night is literally just going to move every single inch of perfect.
Good.
Okay.
Okay? Now,
Well, yeah, but I'm going to have to, because I don't want to fail this flipping test.
It is on Friday.
Well,
okay, here we go, guys. Come on.
Yeah, but
What kind of problem is it?
what?
Equation. How do you know it's an equation?
as an equal.
As an equal symbol. Hey, what kind of equation is it?
Quadratic.
How do you know that?
Because the highest exponent is
Highest exponent is a 2. Excellent. And this one is a special case. How do I know that?
Because it's something.
Something squared equals a number term. Does it matter that it's an x plus 1 squared?
No.
Nope. It's still something squared. Right? Okay? So pay close attention. So all I'm going to do is unsquare both sides. So I'll take the square root of this side and I'll take the square root of this side. On this side, the square root of something squared, those two things are simply going to eliminate each other. They eliminate each other. What's that going to leave me with on this side? There you go. And now that it's not squared, do I need it in a bracket anymore? No. On this side, 16, what times itself is 16?
4.
And what? Yeah, I need both of them. Now, that means that this, but is my x completely by itself?
No.
That means I'm not done.
Oh my gosh. Oh, what?
Oh, guys, come on.
What?
Not nearly as tired of it as me. Come on. Not this. I love this.
The material.
No. Well, you should know the material too. Come on. All right, here we go. Yes, Emily, you had a question? So we just made two equations, and we're gonna solve each one. And over here, subtract 1. The ones will subtract away. Gives me x equals what? Be careful, because the signs are the same, so you'll keep the sign and add, right? So my completed answer is x equals 3, comma, negative 5.
That was a lot harder than I thought it would be, and I'm not happy about it. Can I please take a second to write that down?
There was only 2 steps. It was like the easiest one.
I'm not.
Remember, we're still recording too, so. All right. X squared plus 2 equals 18. Is it an equation?
Yes.
How do you know? Is it quadratic? How do you know? X squared. Right, there you go. Highest exponent is a 2. We have an x squared and we have number terms. Right? So is it the special case? Well, but remember I said that as long as we can isolate that square and get it to be x squared equals a number, it's still the special case. Okay? Is that a square and all numbers?
No.
Then that's not the special case. Is this a square and all numbers?
Yes.
Yes. So it will be the special case because I can get all the numbers on one side by themselves, right? Okay. So you may have to manipulate it a little bit first. Okay. That's what I said by that first step. Remember, the first step was to isolate the square, get the square completely by itself. So sometimes it might not be by itself to begin with, so we'll have to do something.
So would that be a special case?
Yes, it is. Okay? Because what can I do to get that x squared by itself?
You minus 2 from both sides.
Subtract 2 from both sides, which gives me x squared equals what? Okay?
How is that a special case?
Because it's a square and all numbers, right? So can I move this number to that side to be with that number? Yeah. And so that gives me x squared equals 16, which should look very familiar. So what do I need to do?
Do everything again.
Take the square root of both sides, which gives me x equals what?
4 and minus 4.
Done. Okay.
Let me write this down because I literally just finished writing this.
Okay, let's say we have y squared minus 5 equals 20.
Wait, how do you get that?
I just made it up out of my head. Okay. Yeah, we'll do one of each one of, but not this one yet. Let's do this one together, okay? So, is this a special case? Yes, because I have y squared and everything else are what? Number terms, right? Okay. So this is a special case. So I need, but it's a little messed up because the y squared is not what?
By itself.
By itself. Good. How do I get it by itself? Well, look at it. It's got the 5 with it, right? All right, I'm going to add 5. Why am I going to add 5 this time?
So you get rid of the minus.
Yeah, because you want the opposite, so they'll eliminate each other. So that gives me y squared equals, no, you're not going to get me, 25.
How do you get 20? Oh, you plus
20 and 5. All right, now, to unsquare the y, I simply take the what? Square root of what? Both sides. What is the square root of y squared? Plain old y. What is the square roots of 25?
5 and minus 5.
Oh, my.
You're done.
How come it's minus 5?
You get